Hi everyone, and welcome back to our humidification webcast series. Today we're going to be exploring isothermal dispersion, what it is, how it works, and what to consider when designing around it. Once again, I'm joined by my colleague, David Baird, application engineer here at DriSteem. David has helped countless customers optimize isothermal humidification designs, and he has a deep understanding of our equipment's performance and system integration. So David, let's jump in. I think where I want to start today is kind of, first off, what does isothermal humidification mean?
I was thinking you wanted to start there because now you're name dropping something we didn't cover in the previous one. So isothermal means that we're going to put all the energy into the water in order to cause the phase change.
Sure.
And we typically associate that with a steam system. So isothermal, think of steam. We're putting all the energy into it. The other type, which we may touch on later, is adiabatic. And that's where you take energy out of the air in order to cause the phase change. Think of it as misting. What little water droplets, and you're taking energy out of the air.
Sure.
Isothermal just implies that hey, the temperature stays the same because you've already put all the energy into the water.
Okay. And so I know in the last session we talked briefly about steam generation methods. And so how is a humidification system different when we're using a boiler or making steam elsewhere? And when should we be using each one?
In general, I like to think of it as use whatever energy source is most readily available and cheapest to operate. And what I mean by that is if you already have steam available from a boiler and you can tap into it, well, why not? You don't have to make it because you've already got a device to do that. If you don't have that available, then you're forced to make the steam initially. And that can be done either with natural gas, electricity, you can do it indirectly. Some way you've got to put all the energy into the water to cause the phase change. How it's different is if it's under pressure, and when I say from a boiler, I'm thinking of PSIs because the boiler's operating, let's say, 5 PSI or even higher. You can use smaller piping. It's under pressure to get it from one spot to another. And from a boiler standpoint, now you need to control how much there is. And so you're going to have a valve regulating how much moisture to go into the dispersion panel. Versus you can regulate heaters or a gas burner in order to do that same thing if you don't have the boiler already.
When we start thinking about, okay, we have our steam source, how would you then distribute the steam within an airstream? And maybe what are some of the dry steam options that a person could consider?
So in general, it depends on what your goals are.
Sure.
If your goals are to humidify an entire building, the fewest piece of equipment is the most economical solution. In that case, potentially going into an air handler if it is serving a lot of the different spaces. And so putting that steam directly into the air handler or in the discharge duct out of it would be practical. You have to kind of consider at that point then the air is going everywhere, which means the moisture is going everywhere. And so how do I determine whether I've got enough or too much? So you have to understand that, okay, what's my control point? Is it in one room or am I aggregating that across the entire building? If you have a space where you're trying to control just a specific one, I only need this space at a specific condition, you've got to get into individual control. In that case, then you're typically looking at a branch duct. Or maybe you've got a hospital and you're trying to humidify the entire building to a reasonable level, but you have a burn unit that needs to be at a higher level. Well, you could do the base level at the air handler and then add an additional one, basically a trim, in order to handle that special space. So you can get it beyond what its base level is to where you want it for that specific space. So that way you don't have to size it as large.
So let's say we are going to be placing some sort of isothermal dispersion unit within to an air handler. Where is the best place within an air handler to put a dispersion unit?
Well, one of the key things to understand is that it takes a little bit for steam to absorb. You add it into an airstream. And one of the key pieces to keep in mind is the closer towards saturation, the longer it takes to absorb. So if you put a steam system into a cool airstream, it's going to be closer towards saturation. So putting it before the heating coil is generally a bad idea. The air can't hold as much. And so that is where we wouldn't suggest that. You're just more limited in how much you can put into that cooler airstream, and it takes longer to dissipate.
Mhm.
So being after the heating coil. Then after that, okay, do you go after the heating coil potentially before a cooling coil? And sometimes people like doing that because if you do get any moisture carry over, hey, there's a cooling coil with a drain pan.
Mm.
And so that may be a good choice. But you have to consider if you're going to be doing humidification and cooling, if it comes across a cool surface, you may remove some of that moisture you've just added. If you're not going to do both those processes, then that'd be just fine. Otherwise, going after the cooling coil would be just fine. Doing it in an air handler tend to have a little lower velocity. You've got more space available. You have to extend the air handler a little bit to allocate for it. Or going in the discharge ductwork would be just fine. And partially depends on the profile you're working with. Steam humidifiers can handle a wide range of air velocities, whether it's within the air handler or in the discharge duct, which the air is moving faster.
Okay, interesting. So when I'm installing it within an air handler, like what are maybe the considerations that I need to be aware of? Like how do I install that within an air handler? Do I need to blank it off? Do I need bypasses? Like how does all of that work?
So going back to, okay, if we're going in an air handler, you're shoving the entire dispersion array within the air handler. And you've got your connection to bring the steam in, and you've got a drain connection and potentially some structural support. And so when you think of that, okay, that's outside of the potentially the airstream. And so we want to have the steam in contact with as much of the air as possible, because then it'll dissipate faster. It'll take a shorter distance to basically absorb.
Sure.
So if you were to put that in there, just knowing, okay, you've got a drain connection and you want to cause the steam to go out into the airstream and not down the drain. That's where a water seal is typically required. Well, that means that you're putting that space underneath the air handler as a result. Okay, is the air going to go right around it, meaning that we're adding this moisture to less volume of air? If we do that, that's going to mean it's going to be a higher relative humidity. It's more concentrated in that section versus the air that's going underneath it or potentially even on the sides. Meaning, okay, it'll take a little bit longer. It'll mix with the air that's bypassing around it. So aggregate, you get what you want, but you plan for worst case, right? We design around that. So you're going to expect, okay, if I'm only adding the moisture to a smaller air volume, it's going to take longer to dissipate. If you were to blank it off, cause all the air to go right through the dispersion panel, then, okay, it'll absorb faster, but now you've got a pressure drop that comes into play because air has to change direction. If it's paired right up with a coil right afterwards, it's already in that size, but rarely is the size of your cooling coil or heating coil going to match up with the size of your dispersion array, as an example. So you have some transition, how that's done. You just have to factor that in. The pressure drop through the device isn't normally very much, but you have to plan if it's going along and all of a sudden hits a wall before it has to go through the dispersion array. You have to plan for it. It's a system effect on your fans and account for it.
All right. Are there any safeties I need to plan for?
Key things to keep in mind is if you're adding the moisture and there's no airflow, the steam's just going to stay right where it is. And you don't want it to hit against the walls. The whole goal is to keep it within the airstream. So you want to make sure that you can prove airflow. Whether an airflow switch is commonly done, if you have another way to know, hey, the fans are running in an audit, maybe it's a control piece in the air handler you hook into. But you want to make sure that there is air moving through so you can add that moisture to it. The other piece is you want to make sure that you don't add too much moisture, right? You don't want to get in a runaway condition. If that's the case, a high limit humidistat is an important piece. If we think about a space, you're trying to control the space at the end of the day. That may be at a different temperature than what is going through the air handler.
Sure.
And so that's where understanding, okay, what is that relative humidity in the airstream versus what I want in the space? If that's the case, okay, set it at 80, 90% as an example. You want to give yourself some buffer so you don't hit towards saturation. If you do, that's going to potentially condense, and you don't want water in an airstream. You want it to be just water vapor. You want it to be steam. You don't want to cause any chances of standing water, potentially with mold or other things in the airstream.
Sure.
We want to avoid that at all costs.
Okay. Dispersion panels are one of our specialties. What are some of the key advantages of the different dry steam dispersion options?
There's a number of them. I think oftentimes it's how much capacity are you trying to do? If you're doing a little bit of moisture addition, you can do it with maybe a single tube, just one little piece. The higher capacity, you need to be able to distribute it over a wider space. You just need contact points. And I guess that's one of the other things we talked about. Hey, the higher the relative humidity that's leaving, the longer it's going to take. But the other principle that comes into play is the more contact points between the steam and the air, the faster it absorbs. And so by having more and more tubes, you create more contact points. So that's something that can be beneficial, is by spreading it out across the whole airstream versus putting it in one little corner and hoping it'll mix with the rest of the airstream. Mm-hmm. Kind of going back to that bypass example, you want it to be in contact with as much of the air as possible. And having a complete assembly makes life easier, especially if you're going into an air handler. If it goes in like a coil with a frame already around it, it's already pre-built versus had to assemble on site. That can make life easier. Planning for how am I going to get the steam into it and how am I going to do a drain? Because there were some of those inefficiencies we talked about. We need to make sure we can remove that because you don't want it to make it into the airstream. You manage that accordingly. And so some of the different devices allow you to be able to apply it partially based on capacity. Sometimes it's how easy it is to connect to. How much clearance do I need around it, as an example? How thick is the frame or a header? Different things to kind of think through when you're trying to apply it within an airstream.
Sure. So when we are thinking about our steam dispersion system, what are some of the key performance characteristics that we need to be aware of?
Some of the key things is we talked about efficiency. We want to keep it steam as much as possible. And so you want to reduce those inefficiencies as much as possible. So we mentioned insulation as an example. That's a key way to keep the tubes hot. It's not going to collapse back. We have to think through how long is it going to take for that steam cloud to dissipate. That's another key piece. And then we have to think through the air pressure drop. Okay, if you add more tubes, are you adding more pressure drop? To a degree, depending upon how they're shaped. So you're trying to balance on those different things. The air temperature has a big part of it. Mm-hmm. Is when you're designing it, plan for kind of your worst case. If the air is warmer, it's going to dissipate faster. And so understanding that is a key piece. If airflow volume changes, now you've changed your mass, you maybe need more or less moisture addition to it. So making sure that you're solid when we talk about load and also your dispersion. What is the air volume? What is the air temperatures? And how is it going to go through to make sure I'm balancing that from a performance standpoint?
Some of the things that you mentioned in there, I know that that absorption of the moisture into the airstream is very important. How fast or in like what distance does steam typically absorb? And how could I, as a AHU manufacturer, improve that?
So, if we think back, the closer towards saturation. So the warmer the air, and that's why we said that before a heating coil wasn't necessarily a good spot, because the air is cooler. It's closer towards saturation. So the warmer the air, the faster it's going to dissipate. If then understanding as well how much moisture I'm adding to it, if the steam has more contact with the airstream, it's going to dissipate faster. So that's another key piece. In terms of distances, you can do it as little as 6 inches. Very common in a steam-based system that the worst I've seen is maybe kind of 24 inches or something like in a typical application. Sure. So you have to plan for it. I mean, you have to have space for it. And you have to plan as well. We talked about the safeties. Your high limit humidistat, you want to try and have that as far downstream. You don't want it to be in a spot where it hasn't had a chance to mix. And so putting that as far downstream as you can before you get into wetting components. You don't want to get any moisture entrained on your fan blades, as an example, or something like that, if that's further downstream. So, kind of planning for that, but most of the time it's focused on that non-wetting. And then getting a representative sample for your high limit to make sure your safety is working as you want it to be. You don't want to get into turning vanes or something down the road and those are getting wet and you didn't know it.
Sure.
Put it beforehand to protect those devices where it could impinge.
All right. How much pressure drop do I need to plan for when implementing an isothermal dispersion unit?
We talked about the contact points. The more contact points, the faster it absorbs. There's a marginal increase in pressure drop. Now, you have to keep in mind here that they're round tubes, so the air can go around it. It's not like a brick wall
Sure.
that it's running into. A square surface would be greater impact. It can flow right around it relatively easy. In terms of an absolute, typically 1/10 of an inch or less is very common, even at the tightest tube spacing. What you have to consider as a designer, though, is how is the air moving through it? We talked about that blank off portion. You have to allocate that system effect, and how that's done is another piece you have to add. When you're going through it, what the air velocity is going through it, and we'll plan for that. But we can't plan if you're going to taper it really nicely into the airstream so you minimize that pressure drop, or if it simply hits a wall and has no choice but to turn into that dispersion device. And that's one of the things to balance, is if you let the air go underneath the panel, we're talking about that bypass, you reduce your pressure drop. You don't take that into account, that system effect.
Sure.
But there was that consequence because you have less volume of air that you're adding moisture to initially. So it's a balance between these different things. And partially knowing what space you have available will drive that a bit. Making sure you're considering that pressure drop, and making sure you're taking into account the system effect potentially by a blank off panel.
How do I balance then those performance pieces that you're discussing versus the cost?
It's a difficult conversation because figuring out the exact performance, how long it's going to take, will depend on a number of factors. We talked about temperature, how close to saturation it is, how many contact points there are. You really have to get into more of an engineering analysis to kind of evaluate that. And once you kind of know what those are, then you can start balancing cost. And selection software tends to be the easiest way to kind of evaluate those holistically.
Sure.
Hey, if I put the tubes closer together or further apart, how much is that going to change my cost or my non-wetting distance? And unfortunately, the math is complicated. So trust the selection software to kind of figure that part out. There's some nomographs that I've seen as well that kind of give you an idea what that is. Not that it's a term that we think of very often, but kind of a chart that can be used. It is a pivot point. Just like we're talking about, even that whether you blanket off or bypass, each of those different decision points will impact their performance and then your cost. Because if you have a long section, it means your air handler is more expensive, or you need to allocate more space in your ductwork. And so understanding what space you have available will sometimes constrict exactly what you can do in the first place.
Okay. When we're thinking about getting steam up to the dispersion system, what are some of the considerations I need to be aware of?
So if you don't have the steam out of a boiler, if it's in a boiler, you want to make sure that you're getting relatively clean. You don't want to take off the bottom of the steam main where you've got condensate rolling through it. So in that case, it's a little different application, but you want to make sure you have drip tees and stuff to remove any entrained condensate so the dispersion device can handle it. But you might as well mitigate it first, make it work optimally. If you don't have a boiler and you're working off a generator, then understanding where is the condensate going to get out of the system. Water's naturally going to fall downhill. So gravity is going to be a key piece. And if it's close by, can I pitch it back into the generator and it dumps back in the tank? Or is it going to go towards that dispersion device? Oftentimes, site conditions kind of determine that. It's not always a straight run going from point A to point B. You may have to do twists and turns. And so you always have to think through, where is any entrained condensate? And when it collapses from steam to water, how is it going to get out of the system? Where is it pitched and where is it getting out? And the less that you can have once it hits the dispersion, the less risk you have of it even making it to the airstream to begin with.
What role does moisture management play in isothermal dispersion? And when should insulation or a drip pan be considered?
When we think of putting a steam humidifier, it's starting as steam. It's not starting as water droplets. That is being managed already within the dispersion device. And so do you need a drip pan underneath it? Not normally, because the whole point is to try and keep the steam away from the outside walls. We said, hey, you want to make sure that you are improving airflow. If there's no airflow, it's going to hit against the outside, which may be cooler and condense. You don't want that to happen. And so in a properly designed system, a drain pan isn't required. You've got those safeties. You're checking to make sure that you're not adding too much moisture. You're not getting towards that saturation point. Those safeties are key in order to make sure that you're mitigating that. And understanding, okay, having that non-wetting distance is important. Keeping stuff out of that range. If you get into final filters or something like that, that may be more restrictive than typical. You have to kind of plan for, okay, is that going to grab any of the moisture that I've just added into it? Mm-hmm. Okay, that could be a concern. Give yourself some more buffer space to make sure it's fully mixed and absorbed. It's homogeneous before it hits those devices. And so the moisture management, those safeties are key pieces. And, hey, if you want to do a steam generator, if you're worried about that and it's over some sensitive piece of equipment, put a drain pan under it. You're protecting. Okay, sure. There's water in that tank. But in a dispersion system, the water is being managed going down the drain. And so as long as that header's pitch and the water seal's there, which is what you'd use to kind of cause the steam to go out the tubelets and not out the bottom of the drain, if that can freely flow, you don't have any water in that dispersion system. It's all steam.
So again, I'm putting this thing into my air handler, but if I'm not integrated with DriSteam's tech software, how do I kind of get a real picture of what does this look like within my system?
We've determined the performance, but then how big is the headers? Where are the connections going to be? You're trying to coordinate that. And so BIM models can be really helpful. Otherwise, engineering drawings, catalogs help provide a picture of what is each of these different dispersion devices look like. Does it have frame around it? Does it not? How big is this? How thick is it? That'll help. And anytime you get into one and you want to know exactly what one looks, because they may be different. Mm-hmm. Tailoring it exactly to what the application is. You change the on centers, you change the size. No air handler is built exactly the same.
Sure.
And so getting into a custom drawing to know exactly what yours look like, it's something our drafting team does quite often. That way you get a visual of, this is what it looks like. Here's what I need to plan for. How much space do I need to leave underneath it to make sure you're installing it correctly?
And so, that was actually my last question. So again, David, I really want to thank you for this incredibly helpful look into all of the design considerations we need to be aware of when we're considering isothermal dispersion systems. From the pressure drop to the moisture management, there's a lot to keep in mind. Of course, DriSteam offers all sorts of support and tools in order to handle all of these different variables, such as our DriCalc software and all of our other great resources that you can find out on DriSteam.com. And audience, I look forward to seeing you again at our next webcast, where we'll be taking a closer look at adiabatic dispersion. Completely different approach with its own benefits and challenges. So again, don't forget, you can explore any technical content and anything else related to humidification on DriSteam.com. Thank you so much.